Hello boys and girls, this is Learning Target 5, Block 2. We're going to go back to writing proofs using definitions, postulates, and theorems, kind of the second part of Block 5. We're going to today just review some of the algebra skills that we know. We've never used them in a two-column proof, but essentially anytime you solve an algebra equation, you're using a two-column proof. So we've got about half a dozen properties here that you may use throughout the geometry class again, and we just want to remind you of the name for them. So the first one, addition, second one, subtraction. Basically what this is saying is that you are going to add the same thing to both sides. Okay? You're going to add to both sides. And likewise, down here for subtraction, you are going to subtract. And it's important just to remember that it has to be the same. Down below, you do the same thing with multiplication. Multiply both sides. And then finally it's divide. The substitution property is one we'll use often. It's when you replace one thing with another. So you think about in basketball, you make a substitution. You replace one player for another player. And then finally, the distributive property is just distributing over a parenthesis. Over a parentheses. So what do those things look like? Well, sometimes we'll have some algebra examples here, sometimes we'll have some math examples. This one in statement 1, back up on the top, you've got AB minus 3 equals 10. If we want to solve for B, for AB, just add 3 to both sides. And then you'll find out that AB is equal to 13. And that's the addition. All you need to say there is addition. It's not the act of adding, it's what you get at the end. So the plus 3 is just there to help us. The AB equals 13 is actually your statement for number 2. If we're trying to find the measure of angle 1, we sometimes will subtract other angles. So you will find out that the measure of angle 1 is 35 degrees. Subtraction. We do this a lot when we know the measure of one angle and there's a relationship, maybe they're a linear pair or they're complementary. Well, we're going to have to subtract off some other measure. Alright, this one already has division in it. The way we undo division is multiplication, so I would multiply both sides by 2. The 2's cancel out on this side, leaving us with x, and it's 2 times 3, which is 6. There's your multiplication. All of these properties of equality. And then if we have multiplication in front already, you would divide both sides. So x equals 3. Division. This one we will use a lot. So this is an important one. Right here we've got the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Then the measure of angle 3 shows up again. Anytime you know two things are equal, you can replace one with the other. So instead of saying the measure of angle 3, we're going to replace that with 110. But we can still write the rest of the equation. 110 plus the measure of angle 4 will equal 180 degrees. And from here, you can kind of start to see how we might use this to figure out or to prove the measure of an angle. Because now we could combine this with subtraction, subtracting 110, and we would have the measure of angle 4. This is substitution. And the last one, distributive. We won't see this one as often in geometry, though it does happen. When we distribute to 3, you've had 3x plus 3 times 4 is 12, and this is distributive. Distributive property. So these are some algebra examples. We're going to practice these two-column proofs using some algebra reasoning. You know, we've solved things like this in this class. You did it a lot in nonlinear algebra last year. But to kind of emphasize how a two-column proof works, we're going to solve this, but we're also going to give a reason for every step. You should be able to justify each thing that you do. So if I'm looking at this first statement, I know that we are given this. In any two-column proof, you're always going to be given something. Then our first step is going to be distribute. So I will have statement 2 now, 10x minus 5 equals 9x plus 2. And that step was distribute. Then I say we need to get all the x's onto one side. So you're going to subtract 9x from both sides. Subtracting 9x over here. Now we write statement 3 as the result. So 10x minus 9x is just 1x minus 5 equals, over here the 9x, subtract 9x went away, just left with 2. So I'll go over to my reasons, statement 3, subtraction. That's how we got there. The subtraction property says that we can do this. And then finally the last step is going to be adding 5. So I will add 5, and the result is my statement 4. X is equal to 5 plus 2 is 7. And that is addition. Now, we're not going to be asking you to do all this work for simple algebra questions. This is just an example of what a two-column proof can look like. We're going to be given some information. We're going to follow the rules of math and the rules of logic, and we're going to try to end or come to a conclusion like, hey, x actually equals 7. Now, this is an algebra problem, but the same thing is going to apply in geometry. We are going to be given some information. We're going to have to use the laws and rules of geometry to try to reach a conclusion. Oftentimes, I'm going to tell you what it is that we want to try to do. And that's really, in essence, what a proof is. Using the rules to get to something in a logical way. You can't just say x equals 7. This is the proof that truly x equals 7. I want you to try to do number 1, or the second example on this page, and see if you can follow the steps and just get in a pattern here of writing a statement and a reason. Paying careful attention to numbering, like I have here. We've got 1, 2, 3, 4. Matches up over on this side. 1, 2, 3, 4. That's an expectation that I will have. You also want to try to keep them in line. Right? So as you begin to see here, like horizontally, all of these things match up. If statement 3 took a little bit more space, then statement 4 lines up as well. So again, practice these things, keeping them organized, and see if you can do the second question on this page. Pause the video while you try. Okay, we are going to go on to one more page here, and I want to give you some examples of geometry, how we're going to use this in a geometry sense. So we have three properties here. We're just going to briefly go over each of them. The first is the reflexive property. When you think of reflexive, you need to think of a mirror. Okay? If I look in the mirror, I see myself. If you look in the mirror, you see yourself. So it's a redundant, it seems like a silly property, but it's actually quite useful later in the chapter here. But you'll find that for real numbers, A equals A. It seems like a silly statement, but it actually does come in handy that this is a true statement, and it's a reflexive property. For segments, we know that AB, the measure of AB, is equal to the measure of AB. And then finally, for an angle, we know that the measure of angle A is equal to the measure of angle A. That's the reflexive property. When you see something equal to itself, A looks in the mirror, sees A. Segment AB sees segment AB. The symmetric property, this one we don't use very much. So I'll give you an example here. It tells us that if A equals B, then B must also equal A. It's kind of a flip-flop property. We're not going to use this one very much. You can kind of ignore it. Here is the most important one, though. Transitive. This one we use a lot. This is kind of like the chain rule when we were doing logic. When you connect two statements, here, I'll zoom in on this one. The first one, what we know is that A is equal to B. And C is also equal to B. C is also equal to B. I'm going to color C one last new color. If A is equal to B and C is equal to B, what new statement can we conclude? Well, A must be equal to C. We know that if they're equal to the same thing, they're equal to each other. That carries on with segments and with angles. Here again, you'll see our common link, CD. AB is equal to CD. EF is equal to CD. Therefore, AB must be equal to EF. And then finally, with angles, if you got the measure of angle A is equal to B, and the measure of angle C is equal to B, then the measure of angle A must be equal to the measure of angle C. So these are more geometry-based, and we will use the transitive and reflexive quite often along the way. All right, on this page we've got 2 examples and then 2 U-tries, and this is where we're going to end today. I'm going to go through the examples on the left, and then I'm going to ask you to try and do the one on the right. Then I'll come back, try the example number 3, and then I'm going to ask you to try to do example number 4. So let's take a closer look at number 1. Before we set out with anything, we want to look at what we are given. Here I see that I've got some segment marks. Okay, those things mean congruent. And if we look at our first statement here, it's already been converted to an equal sign for us. It says that AB is equal to BC. Okay? Now, what else do I know? Just jotting some things down right here. I've got segments. Okay? This is a segment. It's broken up into little parts. Whenever I think about that, I have to think about the segment addition postulate. Okay? I also think, well, B is in the middle. Maybe it's a midpoint. Now, we're not told that exactly. It doesn't say B is a midpoint. But we do want to start thinking about, hey, if it's in the middle, if you got congruent sides, or congruent segments on each side, then it might be a midpoint. The statements are filled in for you. We're going to do the reasons together. So we're going to start out, let's look at our second statement here. We've got AB, that's the first part, plus BC, that's the second part, equals the entire thing the whole part. To me, that sounds like segment addition. So we know that we've set up a true statement with the segment addition. And this is where your flashcards from Block 1 are really going to come in handy to review some of these older geometry properties. Now, here's a tricky one. Everything has stayed the same. AB stayed the same, equal sign, AC. The only thing that changed was they went from BC, they switched it out, and they put in AB. Sounds like substituted in AB. And if you remember back to your first statement here, AB and BC are equal. So when you have two things that are the same, you can substitute them. This is substitution. Finally, the very last thing that we did, and this is a property from geometry, or from algebra, excuse me, that when you have AB and AB, when you have two of the same thing, you can combine like terms. So this is combine like terms. All right, I'd like you to try and pause the video and do this question on the right. Very similar, though it uses angles this time instead of segments. Very similar setup though. See if you can do number 2. See if you can do number 2. Pause the video now. Okay, number 3 starts to get a little bit more difficult. Now you're not given any statements or anything like that. You need to do all of this on your own. So here's what we're told. The measure of angle 2 is 120 degrees. So I'm looking at my picture and I say, okay, I've got 120 degrees right here. I also see that I've got a straight line. If you remember back to our first Learning Target 5 test, this is called a linear pair. Linear pairs add to 180 degrees. I'm just going to add that at the end here. What we need to show is that the measure of angle 2, that measure of 120, is 2 times as big as the measure of angle 1. So I think I better find the measure of angle 1 and then decide, is the measure of angle 1, if I double it, will I get the measure of angle 2? So let's set this up. First off, we always want to put our given. The measure of angle 2 is equal to 120 degrees. Here's our statements. And our reason. We're always going to start with given. And I like to number mine, so I'm going to put a 1 here. Now the next thing that we need to do is take something from the picture that can help us set up an equation. And we know that the measure of angle 1 plus the measure of angle 2 will equal 180 degrees. And this is the linear pair postulate. I'm going to abbreviate linear pair. Okay, we know that those two things will add to 180. I'm going to take the measure of that angle right there, 120, and I'm going to substitute it for the measure of angle 2. I know the measure of angle 2 is 120, so I can say, you know what, the measure of angle 1 plus 120 is equal to 180. Substitution. I need to get the measure of angle 1 by itself, so I'm going to subtract 120. The measure of angle 1 then is 60 degrees. The act of subtraction. That's how we got there. Subtraction. Now, our key is to remember that we're trying to show the measure of angle 2 is equal to 120 degrees. Well, number 5, the measure of angle 2 is equal to I'm going to go right back to my top statement here. The measure of angle 2 is equal to 120 degrees. Well, the measure of angle 2 is equal to 2 times 60 degrees. 120 is really 2 times 60. And 60 degrees is really the measure of angle 1, because we've got that information right here. And so by substitution, we know that the measure of angle 2 is twice as big as the measure of angle 1. All right, to end today, I would like you to try and do number 4. See if you can come up with a statement and reason. You're going to use the segment addition postulate here, and you will substitute in a very similar way to what we did in number 3. Please have this and the pages all before it completed by the time you come back on Monday. Thank you.